What's up, everyone? Welcome back. Patrick here. Moving on to the next question. So given the demand and cost functions, over here we have the demand function, P of x equals negative 0.06x plus 900, and then the cost function is 600x plus 20,000, where x is the number of units sold. We have to find the maximum profit in two different ways. So the first way we can do this is we can create an actual profit function. And this P here, this is going to be capital P, this is a small p. These are two different functions. This is profit. Remember, this is the demand or the price function. So profit, what does it equal? It equals revenue minus cost. And notice we're given the cost function here, but notice we're not given the revenue function, we're given the demand function. But if you remember, the demand function, which is like the price per unit, revenue is equal to the number of units sold times the price per unit, or the demand function, which is negative 0.06x plus 900, like that. So these two brackets multiplied is the revenue, and then we're going to be subtracting the cost function. You got to be careful, put it in brackets like that, right? You're subtracting that whole cost function. And now from here, we get a profit function. So when we distribute here, we would end up with negative 0.06x squared. This would be 900x. When you distribute the negative inside the bracket, you'll have minus 600x. So you have 900x minus 600x. Those are like terms. So you'd have 300x. And then you'll have the minus 20,000. And so this is the profit function. Notice that this is just a quadratic that's opening down. So we know it's going to have a maximum point. And so we just have to find out what that maximum point is. We're finding the maximum profit, the maximum of this function. So a simple way to do this is you can actually just find the derivative of this. And when you find the derivative, what you would get here is bring the 2 down, so you'd get negative 0.12x plus 300, like that. And to find the maximum point, that's going to happen, so if we have a maximum point, that's going to happen when the derivative, or the slope of the tangent, is equal to 0. So we could find out the x value when the derivative, or the marginal profit, is equal to 0. And so we would end up having, when we isolate for x, we would get x equals 300 divided by 0.12. Right, when we bring this over, divide both sides by 0.12. And so this here ends up being 2,500. So the profit is maximized when there are 2,500 units sold. But notice they're not asking for the number of units sold when there's a maximum profit. They're asking what the actual profit is. So what you would do is you would just take this value and plug it into the profit function. And when you do that, just be careful with your brackets and all, you'd end up getting 355,000. And so that there ends up being the maximum profit. If you were to take this and graph it, basically you'd end up with a quadratic that's opening down, and the maximum point, 2,500 units, and then this, the y value of that maximum point, would be 355,000, like that, right? And it would be opening down. I'm not sure what the intercepts would be, but that's not as important in this question. We're not trying to figure out when does the profit equal 0. We're trying to find out when is the max profit. So it would look something like that, right? And that's where that vertex is going to be located. So that's one way to do it. You can combine the revenue, the cost function, right? Revenue minus costs, and then get a profit function, and then figure out the maximum value of that profit function. Another way to find the maximum profit is to figure out, I wonder if I'll have enough room for this, we'll see. And another way to do it is to figure out when does marginal revenue equal the marginal cost. If you remember from economics, when the marginal revenue equals the marginal cost, then the profit is maximized at that point. And notice that we're given the demand function, but we got the revenue. We can get the revenue function. So you know what? I'm just going to erase all this here. So again, the revenue function is equal to the number of units sold times that demand function, or that price function, which gives us negative 0.06x squared plus 900x. Right? So that's the revenue function right there. So the marginal revenue, or the derivative of the revenue function, both of those are the same thing. The first derivative of the revenue function, or that's the same thing as marginal revenue. This here would end up being negative 0.12x plus 900. That there is the marginal revenue. Now, the cost function, so we'll have c of x equals 600x plus 20,000. What is the marginal cost? Well, it's the first derivative of the total cost function, which is just going to be 600. It's just going to be a constant. So this here is the marginal cost. And so we basically just have to figure out, when does the marginal revenue equal the marginal cost? So we would let the marginal revenue equal the marginal cost, and we just solve for that x value. And notice when we do solve for that x value, bring the 900 over, so 600 minus 900 is negative 300 divided by negative 0.12. The negatives would cancel out. We'd end up getting that same value of 2,500. And then when we take that value of 2,500, in this case we don't have the profit function like we did before, but you could take that 2,500, you could plug it into the revenue function, get the revenue for 2,500 units, then plug it into the cost function for 2,500 units, get the difference between those. It's going to be 355,000 again. All right, so two different ways to do it. Another thing I want to mention is, notice that when profit is maximized, which is at this point, that's not the same point at which revenue is maximized. If you were to find the maximum revenue, so if you found out when does the marginal revenue equal 0, and then you isolated for that x, you'd end up getting 7,500 units, okay, instead of the 2,500. So when revenue is maximized, that doesn't necessarily mean profit is maximized at that same point, because profit takes into account a whole other function, the cost function. So I just wanted to mention that as well. But in this particular case, we're finding the maximum profit. So whichever way you do it, whether you take the profit function, find the maximum of that, or you find out when does marginal revenue equal marginal costs, either way, maximum profit's happening at 2,500 units, and the actual maximum profit is 355,000.